I got this book at a physical bookstore, and someday I'll make a video on that because I actually did make a video on that, but I never posted it, so I probably should do that. I went to a bookstore, a famous bookstore, and I bought a bunch of math books, and this is one of the books that I got. It's called Methods in Analysis, and yeah, let's take a look at this book. It's got like a little design there on the cover. The price was really good. I don't remember what I paid. No, actually I do. I paid $11.95 for this book. So I have the receipt right here. So, oh, look at that. It's nice and blue. Wow. Wow. And I bought this last year. So I haven't had this book for a long time. A series of advanced mathematics text under the editorship of Carl B. Allendorfer. Cool, right? Very nice book. Methods and Analysis by Jack Indritz, Department of Mathematics. Yeah, this is a very old book, 1963. This is from the 60s. Let's take a look at the preface here. This is fun. I love old books. Methods and Analysis is a textbook for a year course whose prerequisite is advanced calculus, the subject normally taken in the junior year. All right. The purpose of this text is to bridge the gap between advanced calculus and graduate analysis courses, supplying the motivation needed for their study and increasing the mathematical maturity of the student. Wow. Okay, so this book is pretty hardcore. Okay, so this book is going to have a lot of things that are challenging, right? So again, it's for a year course whose prerequisite is advanced calculus, right? So pretty advanced stuff. So let's take a look at the contents here. Let's jump into it. Euclidean vector spaces and linear transformations. So that's actually not that crazy. That's fairly, like, I think most people can learn this. Like if you know some, you can learn this, I think. Matrix operators, again, not super intense. Limit processes. It starts to get, when there's proofs, I think that's where some people might have problems. By the way, the pages of this book, the quality is very, very nice. An integral operator, orthonormal sequences, a differential operator, Fourier analysis. Yeah, this book smells incredible. I just have to give it a whiff. There's like this just incredible smell coming from the book. Oh, wow, 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 incredible. This is history. Look at this, vector spaces. So here it talks about vector spaces. This is how the book starts. So if you have some math background, like if you've read math books and stuff, you can read this and say, oh yeah. And many of you have probably seen vector spaces. If you haven't, in theory, you could start here. Here they have proofs. So see, right at the beginning, when you learn vector spaces, they prove the axioms. So if you can understand the proofs and understand how the proof works, then you can learn some proof writing. For example, here's a theorem they have. And then here they have, we begin with property 1. So they're going to prove the first property here. Alpha plus theta is equal to theta plus alpha equals alpha. So for every alpha in this set, you have this condition here. And so they use the axioms. Let's go back over here. They're using these, right? These are the properties. So they use those to do the proof. So by axiom 4, alpha equals 1 times alpha. So that's this one here. See, they're invoking that axiom there. That's their first step. So basically, you would take a piece of paper and a pencil. You'd write down the axioms. You'd work through it. You'd get here, and you'd try to follow along the proof. And that's how you would learn mathematics, right? That's how you would actually learn using a book like this, which I think is great. It takes a lot of time, but you learn some real math, right? And it's starting from the beginning, so that's pretty cool. Here's Schwarz's inequality, the triangle inequality. Already it's getting elevated here, right? You get the proofs, the complexity is definitely going up. You've got some integrals here and stuff. So definitely not a book for the faint of heart. Really fun. Yeah, I got this at a bookstore. I really should make that bookstore video. I probably should make it. I actually recorded footage. So yeah, it's pretty cool. So yeah, just wanted to show you this book. It's got a lot of stuff here. a Fourier integral theorem. Some exercises here. Some more exercises. So a lot of more advanced mathematics. Here's the Fourier transform. Many of you might have already seen the Fourier transform. You might have seen the Laplace transform. There's different transforms. You study the Laplace transform typically when you study differential equations. Sometimes you do the Fourier. It's not typical. The convolution theorem and Parseval's formula. Yeah. I like this. It looks like someone signed it here or something. What's this? Looks like a pen mark. Yeah. Yeah, nice book. Nice tight copy. Methods and Analysis by Indritz. Really beautiful book. I'll try to, if I can find this book, I will leave a link in the description in case you want to check it out. But yeah, a very, very interesting book on analysis here. Methods in Analysis. By the way, if you want to learn math, I actually do have math courses. I even have a course on advanced calculus. They're on my website, mathsorcerer.com. They're actually on the Udemy platform, but if you check out my courses, please use the links from my website. Two reasons. One, it helps me, and I lowered the price to like the bare minimum, so when you use my links, I'm pretty sure you'll get a low price. Yeah, it's mathsorcerer.com or freemathvids.com. I've got calculus courses, trig courses, algebra. I've got an advanced calculus course. It's going to have a lot less material than this book, and it can kind of like help you get to the point where you can read this book, honestly, because again, if you look at the preface, I mean, the author is just straight up telling you that, I mean, the prereq is advanced calculus, right? It's for a year course whose prereq is advanced calculus. So, you know, you want to get through advanced calculus first. And if you don't know, advanced calculus is definitely, in my opinion, the hardest class that a math major takes. I mean, you also take hard classes like topology, you know, and abstract algebra, and maybe your complex variables class is tough or something. But like in general, I think advanced calculus is the one that really, really, really gets people those proofs with you know, real functions and continuity. I have to smell this. Sorry. Oh, it smells amazing. Yeah, look at that. So that's an intersection symbol there. See that? Wow. Double sums, all kinds of stuff. Yeah. Linear transformations. This is linear algebra stuff. So this is stuff that you would see in a linear algebra course. So it says a transformation or operator L on a vector space V to a vector space W is an operation in a subset. Okay. That's called the domain of L, which assigns to each vector alpha, in the domain, the subset, the domain of the, so this is the domain of the linear operator. So it's assigning each vector in the domain another vector L alpha in the codomain, well, they call it the image of alpha under L. Yeah, that would be the image. Correct. Transformations will be denoted by capital letters such as LTU, etc. Two transformations, L sub 1 and L sub 2 on V and W will be called equal if, so for all alpha and the domains. The range of the transformation L is the set of all vectors beta of the form. So they're calling that the range. Very important to get the language right here. Different books will use different notations and languages depending on what you're talking about. Here we're talking about linear operators, though. A transformation L is said to be linear if the domain of L is a linear manifold in V, and if we have this condition here. Cool, right? Really, really cool. So, yeah, nice book. Anyways, I hope it's been helpful. Keep doing mathematics.